In the wetlands of eastern North America, beneath mud, ice, and shallow streams, something moves that should not exist. It doesn't rely on sight. It doesn't rely on smell the way most mammals do. And it certainly doesn't follow the evolutionary path we expect from a burrowing animal. Instead, evolution did something radical. It built a sensory organ so advanced, so specialized, that it looks like a biological glitch. The creature is the star-nosed mole, and nothing about its face is normal. At first glance, the star-nosed mole appears small and unremarkable. It weighs about as much as a deck of cards. Its body is compact, covered in dense, water-repellent fur. Its eyes are tiny and nearly useless. But then you see the star. 22 fleshy appendages radiate outward from its snout in a perfect circular formation. They twitch constantly. They probe. They vibrate. They never stop moving. Each of those appendages is not a finger, but a highly specialized sensory tentacle. Together, they form the most sensitive tactile organ ever discovered in a mammal. More than 25,000 microscopic sensory receptors, called Eimer's organs, cover the surface of the star. To put that into perspective, the human hand, one of the most sensitive structures in our body, contains far fewer concentrated mechanoreceptors per square millimeter than the mole's star. Its face is essentially a living supercomputer for touch. Most mammals rely heavily on sight. Predators track movement. Prey detect danger. Burrowing animals typically compensate with smell and whiskers. The star-nosed mole did something different. Its eyes regressed. In the dark tunnels and flooded marshlands it inhabits, vision offers little advantage. Light rarely penetrates the soil. Water is murky. Mud blocks visibility completely. So natural selection redirected resources. Instead of enhancing vision, evolution dramatically expanded the somatosensory cortex, the brain region responsible for processing touch. In fact, a disproportionately large portion of the mole's brain is devoted entirely to interpreting signals from its star. The result is a sensory system so fast, it borders on incomprehensible. The fastest eater among mammals. Speed is survival underground. In the pitch-black tunnels of wetlands, prey does not linger. Worms retreat. Insects scatter. Aquatic invertebrates vanish in sediment. The star-nosed mole compensates with processing speed, unmatched by other mammals. It can detect a prey item, identify what species it is, decide whether it is edible, and consume it in roughly 120 milliseconds. For comparison, a human blink takes about 300 to 400 milliseconds. The mole completes an entire sensory analysis and feeding action in less than half that time. This makes it one of the fastest foragers ever recorded. And it achieves this not through strength or size, but through neural efficiency. Humans have a fovea in the eye, a region of the retina with extremely high visual acuity. The star-nosed mole has an equivalent structure, but for touch. 2 of its 22 appendages function as a tactile fovea. They are slightly smaller, but packed with even more receptors. When the mole encounters something of interest, it briefly presses these specialized rays against the object for detailed analysis. It is effectively touching in high resolution. The behavior resembles visual scanning, except this scanning happens through direct physical contact, and it happens constantly. If the star were strange enough underground, it becomes even more unusual in water. Unlike most moles, this species is semi-aquatic. It swims efficiently using partially webbed feet and dense fur that traps air for insulation. But here is where it becomes biologically extraordinary. The star-nosed mole can detect prey underwater by blowing tiny air bubbles onto objects and then re-inhaling them. This behavior, known as bubble sniffing, allows it to collect scent molecules in an aquatic environment. Very few mammals demonstrate anything similar. It uses touch to locate the object. It uses air to confirm chemical signals. It makes a decision almost instantly. A multi-layered sensory strategy packed into a body smaller than your hand. Why does it look so extreme? Evolution does not design for beauty. It designs for survival efficiency within a specific niche. Wetlands in the northeastern United States and southeastern Canada are saturated, oxygen-poor, and structurally unstable environments. Soil collapses. Water floods tunnels. Visibility is non-existent. Most burrowing mammals avoid such habitats. The star-nosed mole specialized for them. Its star increases surface contact area dramatically. Instead of sweeping whiskers side to side, It processes entire surfaces in milliseconds. It doesn't search slowly, it samples reality at high speed. And in an ecosystem where prey density is high but unpredictable, rapid identification becomes more valuable. Neuroscientists studying the star-nosed mole discovered something astonishing. Its brain map, the representation of its body within the cortex, is heavily distorted. The star occupies a massive portion of neural territory. This is comparable to how human brains dedicate disproportionate space to our hands and lips. Except in the mole, the distortion is extreme. Its face is its world. Its perception of reality is almost entirely tactile. Where humans build a visual map of space, the mole builds a contact map. Every inch of soil becomes information. Every vibration becomes data. Every brief touch is translated into survival. The star-nosed mole is not a mistake. It is not random. It is what happens when evolution pushes specialization to its limit. And when you look at its face, what appears grotesque is actually precision engineering under environmental pressure. But extreme specialization carries consequence, and not every evolutionary path remains stable forever. Extreme specialization is powerful, but in evolution, power and fragility often grow together. The star-nosed mole is one of the most refined sensory specialists among men. Yet that refinement comes with biological trade-offs that reveal something deeper about how evolution actually works. It does not create perfection, it creates solutions under pressure, and those solutions are rarely flexible. The star-nosed mole thrives in wetlands and saturated soils. Its body is engineered for environments where oxygen is limited. Tunnels collapse easily, and prey is small but abundant. But remove that environment, and the design begins to lose advantage. Unlike more generalized mammals, the star-nosed mole is not adaptable to wide ecological variation. Its sensory star is optimized for close contact detection in confined spaces. In open terrain, where long-distance vision or acute hearing matter more, it would be at a disadvantage. Its eyes are too reduced. Its body is too compact. Its strategy is too dependent on dense, moist substrates. Evolution did not build a universal survivor. It built a specialist. And specialists are efficient only within narrow boundaries. The star never stops moving. Even when the mole is not feeding, the appendages twitch and probe constantly. That level of neural activity requires energy. The star-nosed mole has one of the highest metabolic rates relative to body size among small mammals in its habitat. It must eat frequently, sometimes consuming its own body weight in food within a single day. Speed is not optional. It is mandatory. If it fails to locate enough prey quickly, its high-energy nervous system becomes a liability rather than an advantage. In other words, its greatest strength also locks it into a relentless feeding schedule. When neuroscientists mapped the mole's brain, they discovered something striking. The somatosensory cortex is disproportionately large. The representation of the star occupies enormous cortical space compared to the rest of the body. This means developmental resources, neurons, synaptic networks, blood supply, are heavily invested in tactile processing. Brain real estate is limited. Every region expanded is another region constrained. The mole did not simply gain a sensory organ. It reorganized its neural architecture around it. This is evolutionary commitment. Once a species reorganizes its developmental blueprint so drastically, reversing course becomes unlikely. The lineage becomes dependent on that structure. The star is not an accessory. It is the central pillar of its biology. Wetlands are unpredictable environments. Flooded burrows can become oxygen-poor quickly. Many mammals avoid prolonged submersion for this reason. The star-nosed mole, however, regularly forages underwater. Its blood has a relatively high oxygen-binding capacity for its size. Its behavior reduces time spent exposed above ground, where predators are more common. But this semi-aquatic lifestyle introduces risk. Cold water increases energy demand. Flooding can destroy tunnel systems. Seasonal freezing alters prey availability. The mole survives not because the environment is stable, but because it processes information fast enough to adapt moment by moment. It reacts faster than its ecosystem changes, and in evolutionary terms, that speed becomes survival insurance. Despite its extraordinary sensory system, the star-nosed mole is not dominant in the food chain. Owls, foxes, snakes, and larger mammals prey upon it when it surfaces. Its poor eyesight means it relies heavily on vibration and tactile cues to detect threats. In darkness, this works. In open exposure, it does not. Its body is not armored. Its speed is not designed for long-distance escape. Its claws are optimized for digging, not combat. Again, specialization narrows its defensive option. The star gives it unmatched detection of small prey. It does not protect it from aerial hunters. If the star-nosed mole appears extreme, one might expect evolution to refine it further over time. But evolution does not pursue improvement indefinitely. It stabilizes around what works. The star-nosed mole has existed in a relatively similar for millions of years. Its ecological niche has remained sufficiently stable to maintain the design. When an organism becomes nearly perfectly matched to its environment, selective pressure for major change decreases. The system locks in. This is why its face appears alien, not because it is experimental, but because it is ancient efficiency preserved. Most mammals look familiar to us. 2 eyes, a nose, symmetry we recognize. The star-nosed mole disrupts that familiarity. But biologically, it is no more unnatural than a bat's echolocation or a whale's echolocation system. Both equally radical sensory transformations. What makes it unsettling is visual deviation from our expectations. Evolution does not operate on aesthetic comfort. It operates on environmental feedback. If 22 appendages maximize prey detection in total darkness, then 22 appendages persist. Not because they are elegant, but because they function. The star-nosed mole demonstrates a crucial principle. Evolution is not linear progression toward complexity or intelligence. It is iterative refinement within constraint. The mole did not evolve toward better sight. It evolved toward better touch. It did not become stronger. It became faster at processing micro-decisions. In doing so, it reveals that intelligence in nature does not always appear as cognition. Sometimes it appears as raw processing speed, a nervous system optimized to resolve thousands of tactile data points per minute, a face transformed into a sensory, a brain reorganized around contact rather than vision. Among mammals, few species show such a dramatic redistribution of sensory priority. The star-nosed mole stands as an example of how far specialization can go without collapsing into dysfunction. It is not a mistake. It is not unfinished. It is a solution calibrated so precisely to mud, water, and darkness that outside observers mistake it. But in evolutionary terms, it is one of the clearest demonstrations that nature does not aim for balance, aims for survival within boundary, and sometimes that survival produces something that looks impossible. The wetlands of eastern North America remain silent above ground. Beneath them, tunnels pulse with movement too fast for human perception. A creature smaller than your hand is mapping its world through touch, sampling reality in fractions of a second, rewriting what we assume a mammal should look like. Not broken, not random, just specialized beyond our comfort. And that may be more unsettling than any evolutionary mistake. What looks unnatural often isn't. The star-nosed mole didn't break evolution's rule. It revealed how extreme those rules can become. But it's not the only creature that pushed biology beyond what seems possible. Some evolved eyes that shouldn't work. Some survived environments that should have killed them. Some became predators so specialized they rewrote their ecosystem. If this changed the way you see evolution, the next creature will change it. Watch the next episode of Unnatural Earth, because evolution didn't always follow the rules, and we're only beginning to see how far it went.